Welcome back to the TST100 prototype build. In this video, the bike's going to move under its own power. Then we're going to take it to the dyno, break some stuff, fix some stuff, make some new stuff, dyno it again and break stuff again. So come along for the ride. It's going to be fun. Cheers.
Alright, well, we've just done the first road test on the TST100. I think as far as first test for a completely scratch-built engine, it's been as good as we could hope. Small water leak, small oil leak, both of them I know are there, but the big pluses are, went through the gearbox, went all the way up and down to 6th gear and back again. It feels absolute butter. There's a small vibration in the engine, which we're aware of from the coupler being unbalanced, we think. And everything's work. Our PWM controlled water pump is doing great at holding the temperature where we want, so we get fast warm-ups, but also well-managed temperatures. And I just couldn't be more over the moon, honestly. It's pretty sick. Hey guys, so we're mucking around on the dyno with the TST100, having some challenges as expected with the fuel injection. Just trying to balance the staging of the injectors. This engine setup has 2 injectors as what we call primaries, which are very small. They do the low RPM fuel control, and then we've got much bigger secondary injectors, which are like a shower curtain style that throw it into the throttle bodies. And on Tuner Studio, we program in how the computer swaps the injection over, how much percentage it uses of the little injector, and then adds in the big injector. And we're just finding with this very small engine, it's really difficult to get the control of exactly how much fuel to bring in and when. And it seems very easy to just inadvertently dump heaps of fuel into the crankcase and then flood the thing. So it's definitely a trick for tuning. I'm getting a little frustrated, if I'm honest, but it's part of the journey and I'm sure we'll figure it out. Well, as you can see, it's gone terribly. No, we've got a funny noise coming from the gearbox. I think we might have collapsed one of the little support bearings on the backside of the input shaft. So just double check and make sure it's nothing silly like a clutch basket nuts come loose or something. But at this stage, yeah, no, it's definitely not that. I'm gonna go with it's potentially it sounds like a bearing cage has collapsed and we've got some kind of weird thing going on. But so might be engine apart. Well, it's definitely going to be engine apart, which is going to be a mission. But hey, this is this is the fun of custom shit, I guess. But but yeah, I mean, there's been some real good positives today. We've managed to get it up through the gears, you know, through all 6 gears under full power. We actually made more power than what we initially thought it would do at the moment. So we've already done 22 horsepower, which doesn't sound like a lot in the context of things, but I cannot overstate how badly this is running at the moment. So to be making any sort of horsepower at all is a miracle. So yeah, some promising parts there, and also some frustrating parts. So yeah, I think we'll get to the par. I'll get it back home, strip it down, do a little bit of a look around inside and see what's going on, and yeah, maybe have a rethink of these secondary injector locations as well. But yeah, that's where we got to. All right, well, as you can see, the motor's apart. Found a few little problems in it, which we knew about. As we said earlier, we had a gearbox lock up on us. So got the gearbox out and pretty much did exactly what I thought, which is because these gearboxes from factory are pressure fed through the shafts, and you can see the little hole here where it feeds the oil out. In this engine, we're not using oil pump, so we're just relying on splash lubrication, which is fine. Lots of gearboxes, motocross, things like that work just fine like that. But when you take a gearbox that's designed for pressure feed and did not give it pressure, doesn't like it apparently. So this gear here seized onto that shaft from just simply lack of lubrication. And looking at it, I can see why. There's no possible way for oil to find its way into this journal when the gear is on. There's no voids or air gap or anything where the oil mist can find. There's other parts of the gearbox like here which have the same style. This is just the same thing. This is just a journal. There's no bearing. And this one here looks perfect, but we can also see that the grooves of the spline allow space for oil to find its way in just from the splash lubrication. So the fix at first, we're just going to try carefully grind in some clearance for the oil to find its way. I've got plenty of gearboxes, so I'll get a new shaft and bearing and gear, and we'll give that a go. But so that was our major mechanical failure. The rest of the engine looks beautiful. The pistons barely have any color on them. There's no wear showing, and there's nothing untoward on those, which is really good. Even our primary gear, which we talked about being a little bit noisy, has quietened up a lot as the engine is bed in, but it's not showing any problems on the gear teeth, so that's also good. Crank bearings, everything looks absolutely brilliant. So really happy great opportunity to check everything while we've got it apart. So yeah, sort of as usual with projects like this, 1 step forward, 2 steps back. But we'll sort this gearbox problem out. I've got some thoughts about the injection side to help with our fueling troubles that we're having, to try some new things there, and then we'll get back once we've put it all in place and see how we go. Right, so this is the gear that we were talking about. You can see it's picked up there. That's going to be fine. I'll give that a little polish, and we've given this here a polish as well already. So now what I'm going to do is I'm just going to use the die grinder and cut in a couple little clearance grooves, both on the face and through the gear. So trying to mimic the clearance that those grooves of the spline give this gear, because this gear's been working fine. So that's pretty much the guts of it. Let's get the grinder out and have a go. So see we've ground 4 little grooves in here, so that's to let some oil in along the face of the gear, and then we've also ground some grooves through the gear, which will help distribute oil as it spins around. So when that all goes on like so, and that comes up to here, it's basically just creating clearance for oil to exist. If you have zero clearance for oil to be there, then without the pressure to feed it there, then it won't work. So we'll give this a go and see if it works. If not, we'll solve it with complexity. Right, so as you can see, we've got the TST engine back together. Spent a bit of time messing around with the gearbox, which you would have just seen, just grinding in some oil clearance grooves into the gears, so hoping that that'll allow a bit more space for the oil to spin around and keep those shafts and gears lubricated. The other thing that we've done is added another ½ litre of oil, which is probably overkill. I don't think it's a level issue, but we've got space for more oil, so may as well put it in. So we're getting pretty close now to testing it out. As you can see, we're missing all of our throttle bodies and airbox, so we're about to start some work on modifying that, moving injectors and remaking a whole new throttle body assembly. So lots of new things going in, but hopefully we can start seeing some success with the fuel injection. Alright, so this is our old setup. And so we have these throttle bodies that we bought from just off AliExpress. They're just cheap, a couple, $20 or something. And we had to run 2 throttle cables. So we had this throttle cable splitter here to work the 2 butterflies individually. And these throttle bodies only give you the ability to put 1 injector in the throttle body. It's with the fuel injection with the 2-stroke, the fuel demand at low RPM to high RPM is too vast, that you can only use 1 injector. You have to use 2 injectors. You need a primary and a secondary. So initially the design was we'd have the injector in here as our primary, and then these are the injectors in the airbox, and a bit like a 4-stroke, they would spray out the back of the airbox, and would, in theory, the theory was that they'd spray into the throttle body. I think this was not the best idea, because the 2-stroke engine, if you ever run a 2-stroke without an air filter or an airbox, you'll see a lot of like fog off the back of the carburetor normally, and that's because the resonant frequency of the crankcase of the 2-stroke, you end up with a lot of back pressure bouncing back, and it's like quite complicated with wave dynamics and shit I don't understand honestly. But I think what was happening is a lot of that back pressure was unevenly dispersing the fuel around in the airbox, and then it would overly fuel one side to the other side. Like we were just getting the most erratic fueling. It would be lean and then rich and then lean, and it was unworkable. So we've decided to go away from that completely and just start from scratch with a custom designed set of throttle bodies. So you can see now we have 4 injectors. The ones with the red dots are our primary, so there are our little idle and partial throttle injectors, and then these ones here are our larger ones. It's let us tidy the whole throttle body and injection and fuel system up hugely. So we have a common rail fuel, so that's our fuel supply to the rail, which then supplies all 4 injectors. We've still got our TPS and our return spring here. We delete the twin cable, we can just go to a single cable. So we've got a little brass fitting there that will grab the throttle cable, and then that's our throttle stop here. And then with butterfly throttles, you have to have a limiter to limit the opening, otherwise they'll swing back around and start closing again. And so that's our limiter there to stop it from opening up too far. And really hoping that this is going to be a big improvement in terms of fuel delivery and consistency of fuel delivery over this setup. So we're actually really chuffed with this. This is probably there's a lot of little bits of moving parts in this, and this is the first iteration, and so far as a plastic prototype it looks like it's going to work fine. So we're going to get it on the bike and fire it up and run it with the plastic throttle body first, and then if everything tests out okay, then we'll get it 3D printed in aluminium and go from there. Alright, so we're back at the dyno. Heaps of changes, new throttle bodies, new injector locations, new injector sizes, new fuel control algorithm. So we're basically throwing the baby out with the bath water and starting again. But we've done some street testing so far. It seems to be working pretty good. And yeah, we'll hopefully make some power this time and not foul spark plugs.
Ready?
Well, it's broken again. Same as last time, is nipped that gear on the shaft. So the fix that I did with grinding oil clearance into the gear didn't work, which I was hoping would, because it was the laziest and easiest way to do it. But the silver linings are the new throttle bodies are working fantastically compared to the old setup. Really consistent fueling, and able to make adjustments to the fueling and have the bike consistently respond to that, which is awesome, because last time I couldn't tune it at all. The bike was just so inconsistent and had a mind of its own. Unfortunately, we didn't actually do a power run, but I managed to do a from 4/5, 6 pull, and it's sounding really healthy, which is pretty exciting. So I think just seat of the pants, it feels like we'll definitely be over mid 20 horsepower now. It's running 10 times better than it was last time we did 22 horsepower. So yeah, next step is pull the thing apart again, have another look at this gearbox issue, try figure out how we're going to resolve that. Worst case is we have to put an oil pump in. We'd probably put in a little external electric oil pump in, which will solve the problem, but I really don't want to, so we'll maybe look at putting a needle roller bearing in, or figure out if the issue isn't caused by from just lack of lubrication. It might be getting loaded incorrectly from the case machining not being accurate enough. But yeah, so we'll rip it apart, make a new plan, and go from there. Alright, so following up on the last video, we were at the dyno, and we had what we thought was the gearbox nipping up again. Engine's been apart, found a few interesting things. One is the gearbox, I don't believe, is the problem. This is the gear that last time gave us problem, but you can see it spins beautifully. Has absolutely no notch or any indication that it was nipping up. Certainly not enough that it would make a noise like what we heard. But in closer inspection on the crank, this one here, you probably can't see it, but the thrust washer on this side here has worn a lot, and there's just a bit of colour starting to come into the big end bearing. So this rod and big end is not happy. Really confused at the moment as to how that thrust washer is getting side loaded. I know because I've checked and measured the piston clearance for the pin on the little end. It's got plenty of sideways, so it's not the piston forcing the rod over. I have my suspicion that our $50 Chinese cranks may have come with a pre-bent conrod, and so it's creating a little bit of a side load under load, because this side here feels absolutely perfect. There's nothing on this side. This one's just absolute butter, happy as, and this one here was probably another dyno run away from locking up on the shaft. As soon as that colour's starting to come in, it's not going to last long. So basically, solution for that is I'll keep the Chinese, or the real cheap crank webs, because it's just bits of metal. I've got some new, hopefully better conrods, but now that I have them out, I'll check them all for flatness and all the dimensions for reassembling those with new rods. And then second to that is also, probably you can see in the background, I've been busy on Facebook Marketplace collecting scrap metal basically, but Kyle hooked me up with a milling machine from his work, and then I managed to pick up a nice lathe for a pretty cheap price. So they're both just in the process of getting cleaned up and give them a lick of paint and a good service, and That the mill's going to get a digital readout on it, and then that will give me the accuracy and all of the travels that I need to machine all the cases and everything for this engine, which is, I believe, part of the other problem that we're maybe fighting is the machining is just simply not accurate enough on the mini mill that I used initially. So that's been going on in the background. This has come apart. I don't want to rush it back together now. As I said in the last video or on the dyno, the tuning side of this started looking really promising before we had the noise tune up. So I'm really confident that we're going to make it real good progress with the fuel injection and the throttle bodies now. So I just want to get the motor back together perfect. Like it hasn't been assembled to a point where I've been like really happy with it. It's gone together like good enough. So now if we can get it back together where I go, that's as perfect as I can make it, then I think we'll be in good shape to lean on it and maybe start making some power and get it to a racetrack. But yeah, that's it for now. And yeah, it'll be a little while I get all of this sorted out and then get everything machined up, and then we'll be back into it.